So this may be a slightly different reading from the last test I did, because the laser now is probably at a different height and the meter is probably in a different position. But at the moment I'm using my new grill arrangement. So now I'm going to turn the power off, very carefully take mine off and install the new 3D printed one without moving the laser, so we get a true and accurate record of what the differences are between the two. This is really exciting. Well, the fit was perfect, so there it is installed. I didn't remove the slight stringing. I have to do that with a hot air gun. Now I haven't turned this on yet, so I've got no idea what reading we're going to get on the meter. So let's turn it on and see together. Is that higher? I'm going to have to look back. Was it 2.3 last time? 2.3 to 2.4, and now it's 2.4 to 2.5. And this is the noise. I think that is an even softer noise. That isn't hurting my ears whatsoever. I'm going to have to watch the video back and put the other grill back on for me to listen to. So now do another test, getting the phone closer like it was on the 3D printed one, so you can hear the noise. I think it's quite close, and the wind is still 2.6, so mine I think is slightly better on the wind. As for the noise, we're going to have to do that in post. I think will remake this grill and make the hoops slightly thinner and see whether that makes a difference in that, but I don't think it did, because I think I did the test with it off. So let me take it off and we'll do the test, because that might save me some time. So with no fan whatsoever, very slightly better. So here I am doing another test. This is my revision 1 fan, and that is the wind, and I've repositioned this the same height as the test from all the other videos, and I'm sure that's the same reading. So what I've done now, I've cut some new parts with much thinner supporting rods. One's got 4 and one's got 3, so I'm now going to do a test to see whether the sound gets less or whether the wind goes up. So this is with the thinner grills. Let's have a listen and let's look at the wind. No grill, wind, three, wind, sound. So I've now stacked 2 more spacers on here. These aren't too bad for strength. If you press them they bend very slightly, but I now need to study the video to see whether these have made any difference. So you got this one and you got that one. To the editing room. Okay, we're in a cold garage this morning, 11 degrees, and I've hooked this temperature gauge up to my 20 watt longer laser, and I will show you exactly where it's installed. I just want to take a measurement over a 10-minute burn. A 10-minute burn like that, just a circle. So I just want to record the temperature climb, if it does it at all. The reason being, I'm testing this fan. Once I've done the test, I let the laser cool down. I go and have my lunch, and then I'll put the standard grill back on, and I'll see whether the temperature is any different doing the same burn. We're making plenty of fire, even though the laser is very unfocused. You can see there must be a 50mm gap between the bottom of the shield and the wood, but I am running it at 90% power at 3000. So I just want to get this to climb up. I am obviously standing close by with a water spray bottle, as this is, I can't remember the time, a long test, but you can see the wood is charring quite badly, and I certainly do not want to have a fire. And we are 38% into the test. So 60% through the test, and we've just flicking between 19 and 20 degrees. This is using my new fan shroud. 75% into the test, and we're still holding a steady 20 degrees. Test is almost complete now. I think we're at 92%, 93%, and we're still at 20 degrees. Test completed. So back in my garage this morning, ambient temperature is 14.5 degrees. The laser is back down to 11 degrees C. And this time I've just taken away my honeycomb bed to try and get some more distance between the laser and the workpiece to stop it burning so much. But the test is all about temperature, so that distance is going to have no difference. I've also got a different nozzle. In full disclosure, I've got a 3D printed nozzle on there, which allows me to have 4mm tube going directly into it. I'm running it during this test because I just want to make sure the laser beam is not clipping any part of the plastic. If it does, it will just melt the plastic. So that's why it's in this test. Again, it will have no effect on the temperature that the laser reaches. And I've got the metal fan cover back on. So this will be a fair test of the laser, because it's been sitting here all night. So it's going to be exactly the same core temperature as when I did the test with my adapted fan cover on. So let me just start the wind and get the cover on, and we'll see how quickly or slowly the temperature rises. Okay, let's start the test. Same program as yesterday. Go to cut and layers. So it's at 3090% power. Trying to do it left-handed. and we're off. So it's just the same standard engraving pattern. Now you can clearly see now the two laser beams, because I've increased the distance between the bottom of the laser and the workpiece. You can clearly see it's engraving. You can clearly see, hopefully I can't see anything now, but my safety glasses and viewing through a red window. But you can clearly see it's engraving two items because the beams have gone way past the focal point, and now that's been diversion, is that the word? I hope you could hear me what I was saying there. You could clearly see the two beams. Wow, look at that, that's 15 degrees already. I think that we are, where are we? We're 17% in, and that temperature, what's different? Nothing's different. I've got my extract on, metal fin, so is that climbing quicker than my wooden one? I really look forward to seeing the video. That's amazing. And we're at 21% now. I'll come back to you when we're about 50%. Wow, just hit 32% and the temperature is already at 20 degrees. So I'm sure 20 degrees or 21 degrees was my maximum test yesterday when I was using my wooden adapted cover. So I'll come back to you when we're at 50%. So just approaching 50% and we're at 21. And there's the test. So we're now at 60%, 21 degrees, and there's the test. So just starting to flick between 21 and 22 degrees, and that's at 64% now. So you can clearly see the two laser beams here because it's so far out of focus. I mean, I must have 120 mil between the bottom of the laser and the workpiece. So that is about 33 mil, or probably 40 mil more than yesterday. So 22 degrees and we're at 78%. So we're at 82% now, holding at 22 degrees. And I know what some of you are going to say, Andy, you could have used a bath of water to do the testing, and you're exactly right, I could have done, but I didn't think of it at the time. So once I've started the one test, I have to do the same for the second. And I didn't want water splashing around anyway, but you can do water. This far out of focus, I'm not sure whether it'd make any steam anyway. Still at 22 degrees and we're now at 88%, so I don't think it's going to move. Maybe 23, but we have to wait for it to finish. So we're in the last 10% now, we're at 92%, and in the other test, the temperature did start to flick down by 1 degree. We'll just see whether this does the same thing. 94%, 95%, 96%. 97%, 99%, 'So it's holding at 22 degrees. Test complete, and you can see the embers still glowing. Hope you can, cut the glasses off now. When you finish engraving, So make sure that when you finish the engraving or finish working, I mean, that is being fueled by the air coming out from the cooling fan and the air assist. So it's important that even if you're engraving, that you keep an eye on your workpiece. Let me just remove this cover properly. So you can see that really glowing. Let me turn the laser off. And that is just the air assist pump blowing down. So the air assist is now directing right in the middle of that, but I can feel there's a lot of pressure under this nozzle because I've now got 4mm going directly into it. You can see it's still glowing. So that's another reason for having automatic air assist, which I'm working on. So eventually my air assist pump will be controlled by light burn. So it's still going. I'm going to now remove the air assist tube from the pump, and you can see, look, it's extinguishing itself. So that noise is because I've taken the hose off. So there is no wind fueling that now. Oh, where are we? Can't see. So there is no wind fueling that now, and the embers have gone out. So it's just like a barbecue if you're blowing on it. And you can see, because the workpiece was on the aluminium sheet, you can see all the rubbish that has come out of the MDF. Look here where it was actually burning, and then this is just all the rubbish that has come out of the wood. Let's see on the back side. Yeah, it didn't really burn the backside. This is a scrap piece of work that didn't pop out all the way through when I was testing the wooden cover. But you can still see that is really quite charred. Anyway, a bit of alcohol will clean that off, no problem. And that's another reason why I wanted to remove my honeycomb bed, so all that rubbish didn't stick on my honeycomb bed. Anyway, let's go and edit this video and conclude what's actually happened.
Well, congratulations, you made it to the end of my video, so I hope you liked it and you got some valuable information out from it. Well, I think we can see by replacing a standard metal grille cover on my longer RAID 5 20 watt, it did make a difference, and I hope if you try this on any other brand of laser, you also see the improvements that were showed during the making of this video. Yes, it was an advantage because it reduced the sound level. Now the sound level meters are just numbers, but I hope on the recording of the video you did notice the sound become softer rather than sort of a high, harsh, high-pitched squealing noise that these jet engine fans seem to create. And my fan is on 24/7, so when I turn the laser on, the fan is always spinning. So that was one advantage. Now the 10-minute burn test I did, yes, okay, it's not much of a test, but the test did prove that we generated more wind by changing from the metal to the wooden grill, and it reduced the temperature by 2 degrees. Now yes, that's a very short test. My garage was 14 degrees if I remember rightly, so I probably will revisit this test come the summer, because as the ambient temperature goes up, I expect the cooling to get worse. Now when I contacted Longer, they said try to keep the laser below 30 degrees, I believe their figure was. If that's wrong, I'll correct it in a pinned comment below. Now I hear you ask, why didn't I include the burn test of the 3D printed guard? Now if you're the creator of the 3D printed guard, please post a comment below, because I can't find the link that you sent me, and I can't find the Facebook group that you were on that you sent me the link. So if you comment below with the link and your name, I will put a pinned comment below this video to credit you for that design, because it was very nicely designed. Now I didn't include it in the burn test because I believe the people watching this video or my videos are laser people. They're not laser come 3D printers, people. Now if you have a 3D print, you can try it. You did see that it reduced the noise. You did see the wind speed was a little bit lower than the wooden one, so it does make a difference, and the sound is pretty much the same. So if you like a 3D print, once the link appears down below, you could download and have a go. It was nicely designed. It did use aerofoils, so as you saw in the video, the top of the print is much wider with sort of a dual curve either side, tapering down to a very small sort of less than 1 mil section at the bottom below. I printed it with supports because I knew that I wasn't going to use that long term. I purely printed it for a test. It is designed to use no supports because the way the guys designed it, if your printer is good at bridging, the 3D printers among us will know what bridging is. He has designed it with that in mind, and it was quite clever what he did, so full credit to the designer. So what else did I learn during this video? Well, it's quite difficult to stick a temperature sensor on the Longarray 20. Where I placed it wasn't the best. I have a different idea. I'm making a temperature data logger that will record the temperature of the actual housing. So when I do say a longer burn next time, I will strap 3 temperature sensors around the outside and record the temperature rise during say a 1 hour engraving. Okay, the power levels will be low, but the temperature may be similar because, as you may be aware or you may not be aware, when the laser is firing, the laser is at full power. Now you say, Andy, you're talking absolutely rubbish there, but these lasers, as you may know, operate on a PWM signal, and that is 0 or 5 volts, so it's either on or off. What Lightburn does, that's what I use, it is limiting the exposure time. So if you ask for 50% power, the software turns the laser on at full power, but for only 50% of the time. So everything has a... I'm going to have to do a video about this because it gets technical. Anyway, I'm going to leave that there. I'll let you ponder on that. But these lasers, unlike a CO2 laser, they're either on or off, and it's the exposure time that we play with to get less or more power. And yeah, I'm going to leave it there. I can't explain it here now. So look forward to next year. I'm not wishing the time away. It's early December 2024. Early next year I'm going to do cut testing. So I've got the 5, 10 and 20 watt longer. So I'm going to do some experimentation on those to give you some speeds and feeds for different materials. I will be doing some engraving tests to see how much better a lower powered laser is, because as we go up in power the beam size tends to get bigger, and these beams are not perfectly square. A diode laser has a round dot and our diode lasers have a rectangular dot. Some manufacturers claim that the lower power lasers give you a square dot, but I'm yet to prove that to myself, so that's some more videos I will be doing. What else will be happening in the new year? Well, if you comment on this video and say, Andy, can you make a video on XYZ, I will have a look at what your suggestion is, and if I think it's worthy of a video, I will certainly do that. Likewise, if you comment on any of my videos, I will reply as soon as possible. Remember, like you, I have to go to bed, so it takes, at least 12 hours to reply, but I would hopefully reply within 24 hours. I do tend to get the notifications on my phone, so yeah, let's make this a two-way conversation, these videos. Okay, it's me charting my progress on my learning curve with these diode lasers. So I'm not an expert, I'm experimenting every day, learning something new every day, and just trying to pass my knowledge onto you so you don't have to make the errors that I find. And if I find an improvement into making the lasers better, then you can consider whether you want to do that on your laser. So that's about it really. That was quite a good test. I did enjoy doing it, and I look forward to doing the temperature test again in the summer to see whether I still get a 2-degree temperature drop, but I'm expecting it to be worse. That's it. So I'm going to wish you a very good afternoon. As ever, continue to make some happy smoke, and I will hopefully see you in the next video. Cheers for now.